Okay, so for problem 8, for problem 8, we first define two perceptron layers in problem 7. And as I said before, the first layer is just mapping this input into a nonlinear space. So basically this question says, hey, then let's look at the output of each of these 4 or 5. First, the output of the first layer, so that we can say we are mapping our input data into nonlinear space or not. So basically, this equation is just to show that actually the first layer is mapping this input layer into nonlinear space. In order to show this, we defined our results as omega x plus b, which is basically this, and we are doing sigmoid function, I guess. Yep. We're doing sigmoid function to map this input into a nonlinear space. So when we do this, okay, we can see that these 2 dots represents the data from class 1, and these blue dots represent data from class 0. So we can say that before we use this first layer, our data was like this, okay? So it was impossible for a linear classifier to separate this kind of data. However, because the first layer of ANN is just a mapping of, can be seen as a corner that maps a data to a nonlinear space. The result also says that because we mapped this kind of data into a nonlinear space, we can just simply classify this kind of data in one classifier, right? So basically, the first layer just maps our data into some kind of space that a linear classifier can just simply classify. And the second layer will do an easy job of just classifying this kind of two, just figuring out the boundary between these two classes. So this problem is just to show that the first layer of the ANN, multilayer perceptron, is just mapping our data to a nonlinear space so that the second layer can classify this data into two classes very accurately. And second is to visualize the kernel space on 2D plane, okay? So kernel space basically means, so this question is very vague, so I'm not going to emphasize the importance of this question. Just simply look at this question and just enjoy, maybe. So this grid space is a kernel space. So kernel space basically means we want to see how this initial space is mapped to a nonlinear space. How? Okay. So what kind of transformation changed this kind of data into this? So we want to find out that. Okay. So when you see this, okay. So we just made the grid points. Okay, we made the 2D grid points, and we apply the same kernel. Okay, the same kernel. So basically, first this was the data we had, and we applied the kernel, so first layer of our perceptron, and changed this data into this kind of data. So in order to see the impact of this first ANN layer, we're now just mapping this kind of grid into a nonlinear space, and the result shows that this. Okay, so this can be awkward, but this is basically we're mapping all the grid into this kind of small space, which means originally this kind of space will be compressed into this kind of space. So when we compress our space into this, then we can, so this is basically the result. Oh, so I drew wrongly. So this kind of, we changed this kind of grid space into this by using the nonlinear transformation. Okay. So basically, we can just simply say that we've cut this half and we just stick this end to end like this, okay? Then we will show this kind of data, okay? So as we expected, the first layer of the ANN is just simply mapping our space into a nonlinear space so that we can classify better. So basically, first we had a grid space like this, and after we change this grid space into a nonlinear space, we can see that actually the ANN, first layer of the ANN, is just making this grid space folded half, so that we can classify this kind of data more easily. Okay. Right, so plot the decision boundary. So, as I said before, because we had XX and 0, 0 like here, so decision boundary can be simply just drawn like this. So this cannot be any problem for you guys. And drawing a classifying line is always the same, so you don't need to change anything. So basically, this problem A is to show you that the first layer of ANN is mapping the original space into nonlinear space, but how? And we show that it's actually the first layer is just folding this grid space or rectangular space into half, so that these two classes can be located in the same manner. Okay, so we can classify these kind of two classes very easily. So, this ANN is quite interesting because we don't have specific rule to map this nonlinear function. In other like kernel functions that maps the original space to nonlinear function, there is mathematical background. For example, if you transform in the Gaussian space, then our dots like this can be mapped into like this. But there is a specific mathematical formula to transform this nonlinear. However, for ANN, this is kind of magic because they transform data into a space where they can classify better than before. So, although it will be like for this kind of question, it can be beneficial for ANN to just fold this space into like this, but sometimes it can be better if you just fold this into here, like reversely. So basically, the ANN maps the space into nonlinear without any kind of mathematical background, because this means that this ANN have some kind of degree of freedom, so it can be useful when your data is quite messy. Okay, so this is end of question 8. Now we're gonna move on to extra questions. So I want to show you guys some questions that were not involved in the homework problems. So basically, this is the data we had. So this data distribution is quite nonlinear, so linear classification is almost impossible. So we're going to use the multilayer classifier defined in Scikit-learn package, like before. So instead of the other solver that starts with L, we're going to use the stochastic gradient descent method as a solver. And for the hidden layer size, we're going to use 3. And for activation function, we're going to use the logistic function. Max iteration, learning rate, you can decide by your own choice. Actually, every single thing in here is depends on your choice. So you can choose SGD or other solvers. You can just use hidden layer size of 3, 4, 5 is your own choice. And for an activation function, you can use logistic, sigmoid, and tangent h. This is also your choice. And max iteration learning rate is also your choice. So for your exam, that can be like multiple answer, because you may choose anything you want. So normally I just provide some kind of details that you can use for better classification. For example, hey, build a classifier in A and N using the HD solver and just build 3 hidden layers. Then this 2 kind of thing is already decided, so you can just decide rest 3 to write your code. So this cannot be any problem. Now again, this drawing classification line is always repeated, so you don't have to quite know. Okay. So when we do that, we can say that we built 3 hidden layers, right? So we can see that how each hidden layer makes a decision boundary. So the first hidden layer, okay, is in black. Okay. So black line is the first hidden layer. So first hidden layer is just classifying this kind of interface, and the second and third. Second is a green line. Okay, so green line basically is classifying this kind of interfaces. Okay, and the third line is classifying this kind of interfaces. So basically, this 3 classifier is merged to build a new ANN classifier. So let's see. It's a question. Right. So the second question is plot those data in Z-plane, so which means hidden layer. Okay, so if you map this into hidden layer, we can see that this class is separately quite interesting. Okay, in 3D space, you can see that these kind of blue points are gathered in some kind of Z-axis, and also in the orange, the second class is distributed like this kind of space. So this hidden layer is just mapping the original this 2D layer into some kind of nonlinear space, and we can see the nonlinearity very clearly, right? So, for example, this kind of like curve here is basically nonlinear, and also this kind of data distribution, the orange distribution is also nonlinear. So we just map this kind of 2D data in a nonlinear function, and if we build a classifier based on this kind of nonlinear space, then we can simply see that this kind of hyperplane can classify this kind of data into very wisely. Okay, so I think the message is keep repeating. So ANN is basically mapping the original space to nonlinear space so that we can classify this kind of nonlinear space very wisely. However, this nonlinear transformation is already used in many machine learning techniques, but this ANN is different from those kind of machine learning kernel system because it does not depend on any specific mathematical condition. So ANN just basically trains its own nonlinear transformation function to map this kind of data so that our classifier can decide or classify very simply. Okay. So messages keep repeating. So I'm gonna skip this kind of message. Okay. And the 13 problem, this is quite an interesting problem because we keep doing multilayer perceptron classification. So we used MLP classifier for homework problems, but this time we're going to use the MLP regressor. So as you know, the classification and regression is quite different. Regression is to to find out the exact label for each numerical value for each input. However, the classification is to find whether this input belongs to class 1 or class 0. This is quite different. So classification is just is finding the categorical value, so which category this input belongs. But regressor is basically finding the numerical value that each inputs have. So quite different, but this is the data we are given. But method is simple. So basically, we're going to use the MLP regressor, and we get hidden layer size of 100. And using the activation of logistic and max iteration, this kind of is repeating. And we define our regressor as reg. So we just use the reg fit using the x and the label and the y. And y is basically some kind of numbers, right? So in classification, this y, which is our target, will be like class 0, class 1, class 0, class 1, like this. But in the regression, this is kind of different because our regression technique is basically predicting the numerical values. So this can be like 0.12, 0.24, blah, blah, blah. And we are using this x and y as to train this regressor. Okay. And when we finish our trained regressor, we can use this reg.predict to find the specific label for each corresponding the data. For example, so regression, this regressor is fitted, which means the regressor is now defined as some kind of function, fx, okay? So that we can define, so regression. So regression, now when we train this regressor, we can first find a function that maps or just predicts our y when the input data is given. And this, which means this is equal to y, fx is equal to y. So regressor is just run this kind of system, okay? So when we use this regressor.predict xp, it basically means finding the y value for each of xp given. So we have given this kind of arrange x as an xp. So for each data point on the xp, the y regressor will predict the exact value. So we can draw a line like this. Okay. So basically, this xp is just basically a point in this kind of space. So when we given a point like here, like this kind of x point, to a regressor, then regressor will predict the y value for each of x, okay? And we can just point our red mark here, and if you just draw a line for those kind of red marks, then we can just draw this kind of non-linear function that regress on our data, okay? All right, actually this is the last question I prepared.